Good afternoon, I'm Engineer Perfecto Padilla. The Civil Engineering Board exam is just around the corner. We can already smell it. It's less than a month before the April 2023 board exam. In regards to this, I am inviting you to enroll and to attend our coaching program in full preparation for that forthcoming board exam. I guarantee you that this coaching program will mean a lot, will contribute a lot to pass, to top the board exam. In this coaching program, we will be discussing forecast problems and latest board exams. So it will really be an advantage, a great advantage to familiarize yourself in the trending of the board exam. So, and also familiarize yourself with the actual board exam problems. So, when you are familiar with the problems and the simplified solution and approach, and even the answers, then it would really be an advantage. This is a program you cannot afford to miss. In order to enroll, click the link below on padillareviewcenter.com and choose enroll. So, let us have this. This appeared in the last November 22, 2022 CE board exam. So, we have here this rod or pole AB that is 12 meters long and its weight is 35. So, I presume that it is concentrated at the middle of the 6 meters. This pole AB is at an angle of 60 degrees from the x-axis, and this is along the XZ plane. X-axis, Y-axis, Z-axis. It is being supported at point A by a three-dimensional hinge, and this is a pin support. This is cable BC and cable BD. Now, we are asked here, number 1, to find force BC, force BD, and the reaction at support A. Okay? So let us say that the force in BC, let us call this as force T. So that is the magnitude of the force. And the force in DB or BD, let us call this as force P. And let us say that the reaction at A, this one is RA. So there are 3 unknown forces acting on our rod AB. Now don't ever commit the mistake to assume that the force in AB is axial, because there is a transverse load. So the force in AB will be axial because this is pin and this is hinge if there is no load in between the ends. But there is a load between the ends, so this acts like a beam. So there would be a transverse load shear here and axial force and moment in AB. So how are we going to solve RA, T, and P? 3 unknown forces. Now, the principle that we are going to use is this. Isn't it that, for example, you have a truss, this one, let us say this is your truss, hinge, roller, you want the force only in this member. What are you going to do? So you are not interested with the other forces, you are interested only in this member. So what we're going to do is we will use cut and expose or section method. We cut this, then taking the FBD of this, we expose the forces acting here. So, in order to eliminate the 2 other forces, we take the moment at point where both of them are passing through. So, we want this F. So, we take summation of moment about, let us call this C, is equal to 0. In that way, these 2 forces will be eliminated. They will not appear in the equation because their moment at C is 0. So, we will be using the same approach in this problem. For example, we want the magnitude of the force T or the force in BC. If we want T, we will take moment or summation of moment about a point where the two forces RA and P are passing. But there is no common point, or that is difficult to find because RA, the direction of RA is not necessarily or is not yet determined or is not yet defined, no? It is not in the direction of AB. Okay? As I had explained why. So what we're going to do is we will take summation of moment about a line where that is passing through point A where RA is passing and point D where P is passing. In that way, when we take summation of moment at AD is 0, the only force that will appear in the equation is T, right? But how do we get the moment of a force in three-dimensional figure about a certain line AD? This is what we will be needing. What we need is the triple product. So, the moment of a force that is passing through, let us say, for example, this one, this is passing through B. And we want to find its moment about the line AD. So, the moment of a force passing through B about the line AD, so this is equal to the force vector passing through B, multiplied by the distance vector from B to A, meaning that distance vector B to A, XBA, YBA, ZBA, multiplied by the cosine of the direction cosines of AD. When you say direction cosine of AD, B, BA, then AD. Okay? So, it would be the direction cosine of AD, meaning X over D, Y over D, Z over D of AD. Force through B, distance from B to A, then direction cosine of A to D. Cross product, dot product. This is what we will be needing here. You follow? Okay. Also, when you say force vector Fx, Fy, Fz, what is Fx? Your Fx is force times cosine theta x. And that cosine theta x is x over d of the direction of force. Your Fy is force times y over d. Your Fz is force times z over d. Or in vector form, that would be the force vector is simply Fx, that is Fx over d, Fy, Fy over d, Fz, Fz over d. Okay? So we can simply write that if we will factor out F, that is the magnitude F times X over D, Y over D, Z over D. Okay? This is the representation of force vector. Now, so what I'm going to do here in order to solve our T is we take summation of moment about AD. P is passing through that AD. RA is passing through that AD. So RA and P will be eliminated. Let's do it. So by taking summation of moment about AD, AD is equal to 0. So the moment of this force BC, which is T, so is equal to what? The vector force BC. BC passes through B, right? Okay? And we want its moment about AD. So it must be distance from B to A, the distance vector from B to A, dot product of the direction cosine of AD. The direction cosine of AD is X over D, Y over D, Z over D of AD. Meaning XAD, YAD, ZAD over D of AD. Plus, there is another force with moment at AD. That is W. So it would be the force vector of W, okay? W as a vector, meaning WX, WY, WZ. But W acts only along the Z direction, so it has only a Z component, okay? So we will have that a little later. So times the distance W passes through E. So from E, we need the distance from E to A because we need the moment at AD. So distance AA vector, okay, to be multiplied by the direction cosine vector of AD. That is X over D, Y over D, Z over D of AD. This and this are just the same. Okay? You follow? Okay. Let us, and this is equal to 0. This and this are just the same. Okay? Alright. So let me lay this down. FBC is Fx, Fy, Fz. I can write that as the force X over D, Y over D, Z over D of that force. Let us have this. This is the magnitude of FBC is T. T. X, Y, Z of BC. Now let us say, according to the problem, this is 60 degrees. This is along plane XZ. If this is 60 degrees, this is horizontal, this is vertical, this is opposite of 60 degrees, and the pole is 12 meters long. So this one is 12 sine of 60 degrees because it is opposite 60. On your calculator, you'll get this as 6 square root of 3. Let me put this in my calculator as alpha F so that I will just use alpha F every time I need it. Then this one is hypotenuse 12 adjacent to 60, so cosine of 60 degrees. So this is going to be 6. So this one is 6. While this one is 6 square root of 3, which I stored in alpha F. Okay? Now, the X, Y, Z of BC, X, Y, Z of force, from B going to C, you move downward by 6 square root of 3. This is opposite of Z, right? Correct? So, opposite of Z, so negative Z. So, this is negative 6 square root of 3, which is alpha F. I will be using the variable F in my calculator to indicate this one. Then, from here, you move in this direction. That is 6 plus 4.5, 10.5. that is opposite the direction of x. So this is minus 10.5, right? Then you move in this direction 2.5 opposite the positive y. So this is negative 2.5, right? Over d. D is the square root of x squared plus y squared plus z squared. So let me have it. 10.5 squared or square root of 10.5 squared. Pwedeng alisin yung negative kasi squared naman, it will just become positive. Plus 2.5 squared plus alpha f squared. So it would be 14.9832. Okay? So let me store this 14.9832 in memory E of my calculator. So shift store E. So this will be over E, this will be over E, this will be over E. So let me call this portion as vector A. So this is vector A representing FBC, no? So this is force BC. Okay? But vector A can only be entered in your calculator as this. T must be factored out. Okay? Now, cross the distance vector B to A. So from B going to A, this is 6 square root of 3 downward, right? So it is in alpha F, so that is opposite of positive Z. So it is minus alpha F in our calculator. Then from here to A, opposite of positive X, minus 6. That is X. Minus 6. And the Y is 0. So this is the distance vector from B to A. So we prioritize this. Then that product X, Y, Z over D of AD. From A to D, you move 6 or 3 opposite X, so that is minus 3. Then 6 towards positive Y plus 6. And we are already at D, so Z is 0. Over D. Your D is the square root of 3 squared plus 6 squared plus 0 squared. Square root of 3 squared 9 plus 36 45. So this must be square root of 45. Square root of 45. Square root of 45. This is merely 0. Let me call this as my vector B. Vector B. This one, let us store this as vector C, which is the same as this, right? Your W, so plus this one, W as a vector, because it is along Z, then there is no X, there's no Y component. 0, 0, W is opposite the Z direction, so minus, the magnitude is 35. So this is how we write W in vector form. So times W times D from E to A. From E going to A, the X, Y, Z of it. From E going to this, if this is 6 square root of 3, this is 3 square root of 3. 1/2, because this is at the middle. So this is alpha F over 2, right? So we have here opposite the Z, so this is alpha F over 2, and that is downward, so minus. The Z is minus. Then going from here to here, opposite ng X, If this is 6, so meaning this is 3, opposite x. So this is minus 3. And this is 0. Okay? As you can see, if this is vector B, you multiply this by 1/2. You multiply this by 1/2, minus 3. Multiply this by 1/2, 0. Multiply this by 1/2, it's this. So basically, this is vector B over 2 or times 1/2. 1/2 times vector B, right? Right? Okay. Now this is vector C. Okay? So this is minus 3 over square root of 45 plus 6 over square root of 45, while this is 0. Again, this and this are the same. This is vector C. Let us say that this is vector A, B, C. Let me call this vector D. You follow? You get this? Okay. Now, let us store this in our calculator. Let us input mode vector, mode 8, vector A, 1. Okay? Dimension, because this is x, y, z, 3 dimensions, so 1, no? So input mode 8, vector A is 1, dimension 3 is 1, mode 8, 1, 1. Input this. So we will have here minus 10.5 divided by alpha E. Okay? So minus 2.5 divided by alpha E. Then minus F, alpha F, divided by alpha E. So that is your vector A equals. Then to input vector B, this one, press up data. So up to, up, then 2, then vector B, 2 again, then dimension, 3 dimension because x, y, z, so this would be 1. Up to 1, 1 for vector B. Okay? So input now, minus 6 equals 0 equals minus alpha F equals. So this is going to be, this is already entered in vector B. Then let me enter this in vector C. No? So then I press again up. I will just repeat this. Up, data 2, then vector C, that is 3, then dimension for 3 dimension x, y, z, 1. Then input this. So minus 3 divided by square root of 45. So then 6 divided by square root of 45 equals. Then this is 0 equals. So this is already entered in vector C. Let me enter W. So this is W in vector D. Okay? Again, press up. Then data is 2. Vector D is 4. Then dimension, 3 dimension x, y, z is 1. Then enter 0. Please follow me, no? 0 equals, 0 equals. So minus 35 equals. So equals, then that is vector D. Okay? Then we now want to solve this. This is equal to 0. Let me first compute the first part of the equation. So to input this, your vector A, meanwhile, is this. So vector A times T, that is your FBC. Okay? So, let me compute this. Vector A cross vector B dot vector C times T. So, let me compute. So, since I want to prioritize vector A cross vector B, I will use a parenthesis. So, open parenthesis. To input vector A or to enter vector A here, press up, follow me, up 3. So, vector A will appear. So, it would be open parenthesis, then up 3. So, in your calculator, in the display, it's vector A. Then, cross, simple times symbol, then vector B, that is up 4. Up 4. This is vector B. Then close parenthesis. Then dot. To show the dot symbol, press up 8. So up 8 is representing dot. Then, so far, what is displayed in your calculator is open vector A cross vector B close parenthesis dot, then vector C. So, up vector C is 5. Up 5. So, what is now in the screen of your calculator is VCT A cross VCT B, close parenthesis, dot VCT C. Press equals. What you will have will be minus 3.56711. So this is minus 3.56711 of T. Let me now compute this. So this is VCTD. So basically, vector A times vector B times vector C. This is merely vector D times vector B times vector C times 1/2. So I will just use what is in the screen. I will just replace VCTA by VCTB. So I delete it, VCTA, I replace by VCTB. So up, vector D is 6. So far, what is in my screen is vector D times vector B times vector C. I will just multiply it by 1/2, no? So, 1/2 or 0.5 times this times this times this equals. What you'll have here will be 93.9148. So, what I have, this one is minus 3.56711 of T plus this one, what is this? Times 1/2, 93.9148. And this is equal to 0. Your T therefore is, in this equation, 26.33 kilonewtons. This is your T, which is your force BC. Okay? You get this? So, force BC is 26.33. So, let us modify vector A by multiplying vector A by T. So, T is 26.33. So, press it. 26.33 times vector A. So, press up 3. Press equals. Okay? Then, shift store A. So, that will make the new answer as vector A. Correct? So, this time, your vector A is already vector FBC. You get it? So, this is already stored in FBC. You get it? Okay. Now, let us now solve force P. For force P, we will take the moment about AC. So that RA will be eliminated. And so that our BC, force BC, will also be eliminated. You get it? Okay? So, let us take it. So, the moment about, summation of moment about, this time about AC. Okay? About AC. So, it would be force BT or force BD. This is BD times the distance from B to A, because this is AC. So, B to A, which will be still this one, vector B, multiplied by the vector of direction cosine of AC. Right? So, this would be AC. So, this time, it will be different. Plus W times the distance from E to A, same. So, which is vector from E to A, 1/2 of vector B. Right? Now, multiplied by this, the cosine vector or vector of direction cosine of AC. This would be the new one. So, for AC, for FBD, from B to D, that is force P, X, Y, Z of BD. Let me remove this. So, X, Y, Z of BD. From B going to D, you go down by 6 square root of 3. And that is F. Opposite of Z. So, that is minus alpha F. Then, you move, I'm going from B to D. From here to here, that is 6 plus 3, 9. Opposite of X, minus 9. You follow? Okay. Now, then, you move 6 going to positive Y. So, this is positive 6 over D, right? X, Y, Z over D. So, your D is the square root of this plus square root of this plus square root of this. Let me do that. So, this is 15. 15. 15. Okay? Since I have to input this to another vector, but I already consume until vector D. Okay? So, let me just copy the value or write there the value of FBC. So, this is vector FBC. So, this is currently vector A, right? So, let me just write the value here. So, I have here up 3 equals. So, that is vector A. So, this is minus 18.452. Then, the Y component, minus 4.393. Then, the Z component, minus 18.262. Okay? So, this is force PC. Okay? Now, here, this now, we will input as vector A. Okay? Then, this one, DBA is also vector B. So, no problem. Then, X, Y, Z of AC. From A to C, you move 4.5 opposite of X. So, this must be minus 4.5. Okay? And then, 2.5 opposite of Y. So, minus 2.5. We don't move vertically up or vertically down. So Z is 0. Now, the D is the square root of 4.5 squared plus 2.5 squared plus 0 squared. So, that is 5.148. Okay? 5.148. So, I will just change vector C. Okay? So, I will store the answer of 4.5 squared plus 2.5 squared to alpha E. No? Shift, store, E. So, this would be over the square root of 4.5 squared plus 2.5 squared. This is alpha E. Over alpha E. Okay? 0 over alpha E, 0. Okay? So, this will be the same as that, which is vector C. Minus 4.5 minus 2.5 then 0 over E. Okay? Ano yung mga nabago? Ang nabago, the things that was changed ay vector A. This is the same vector C. So, let us change. So, let us have up to data vector A. 1. Okay? I have to change. Minus 9 divided by 15 equals 6 divided by 15 equals minus F, alpha F, divided by 15 equals, that is now your vector A. I also have to change vector C. So, vector C, up to data, no? 3. Up to 3. So that you will go back to C. You have to modify the answer. Minus 4.5 divided by alpha E. So that is minus 2.5 divided by alpha E equals. Then 0 equals. So that is vector C. You follow? Then again, you just proceed with this one. Vector A, up 3, cross up 4, up 8, that is that, up 5. So that will give you this one. Okay? So what we will have will be, I repeat, open parenthesis, so press CA, no? Then open parenthesis, up 3, so that is vector A, times vector B, up 4, close parenthesis, then dot, up 8, then vector C, up 5, equals. So what you will have, you compute this, we get 4.6432 of P plus this one. This is vector D. Just replace this by vector D. So, times 1/2. So, 0.5 times. Remove vector A. Replace it by vector D. Up. Vector D is 6. So, what I have now in my calculator is 0.5 times vector D times vector B times vector C. Press equals. What you will have will be minus 50.9925 is equal to 0. You'll have your P. Your P is force BD. And that is equal to what? This is 10.982 kilonewtons. This is going to be your FBD. Okay? And the force T from previous result is 26.36 kilonewtons. You follow? This is the force in BC. You get it? Now let me input force BD. Let me now input force BD. Force BD is vector A, the new vector A times P, times this. So I have here P 10.982 times vector A up 3 equals. So that is now your force in BD. This one. You get it? So I will now store this in vector B. No? Shift store B. Okay? So it is now in my vector B. Okay? You follow? Okay. So it is FBD. So your FBD is equal to, let me copy it, minus 6.5892, then 4.3926 or 393, then minus 7.609. This is your vector FBD in vector form. Okay? You follow? So I will need them in my resultant. Okay? My W, the W vector is what? 0, 0, minus 35. Okay? You get it? Alright. Now, we need now RA. Okay? We need RA. How do we solve it? So, for RA, this is how we're going to do it. Kindly observe first. Now, since this is in equilibrium, we know that summation of forces is equal to 0. We will vectorize this. We will include the direction. So I have here vector RA, this is the one that is required, plus vector of force BC, this one, force BC, plus vector of force BD, plus vector of W equals 0. So therefore, we can see that RA, you move this to the right, will be minus of FBC plus FBD plus W as vector. So therefore, this is going to be minus of FBC plus FBD plus W. All you need to do is add them. This plus this, you'll get minus 25. This plus this is practically 0. Okay? Then this plus this minus 60.871. Okay? And then you multiply by negative, your RA therefore is equal to 25, 0, plus, minus times minus, 60.871. And the magnitude of RA is simply, the absolute of this, or the square root of 25 squared plus 0 squared plus 60.871 squared. So, computing this would be 65.8 kilonewtons. This is your RA. RA is 65.8. Force BD is 10.98 or 11. T is 26.36. Do you get it? Naintindihan? So, again, as you can see, this problem, because three-dimensional and the forces are not all collinear, and this is not a purely axial member, this is a bit heavy. But although it is heavy, since you already had encountered it, then it will no longer be as heavy the next time around. Okay? So that is the advantage of enrolling in our coaching program. So this is a program you cannot afford to miss. Okay? masayang yung mag-ulit ng review or ng refresher o mag-ulit-ulit ng review 6 months kesa mag-take advantage of this beautiful, comprehensive program. So don't delay. The earlier, the better. You still have time to absorb all the materials. Increase your chance of passing the board exam, topping the board exam by enrolling in our coaching program. The tuition fee for PRC Padilla Review Center reviewees is 3,000, while for non-PRC Padilla reviewees, it would be 5,000. So, see you and kita-kita tayo.
Are you preparing to take the CE licensure exam? Here in Padilla Review Center, we offer online review for civil engineers and variety of other courses. Enrollment is ongoing. Visit our official website to enroll. Are you struggling with your major engineering subjects? Let us help you out. Here in Padilla Review Center, we have subject mastery courses you could enroll for 1,000 pesos per course. What are you waiting for? Enrollment is ongoing.